check it is recording. Alright. So if you go into Moodle, I have already made the test available. Obviously, it's not going to be graded until I get around to it, but you have full access to all the questions at this point. So if you go to cisp360, go to the arrays topic, then you have a link to the shared document on Google Documents. And I think that's really the best way to distribute anything, is to put it in the cloud. There we go. So if you scroll all the way down, it's right after the practice questions. The second link or the second exam 2 is the actual exam 2. So if you click it, it will bring you, you don't even have to sign into anything, because I made it so that anyone with a link can view the document. So this is the document itself. It's just exactly the same document that you saw earlier, with your exam. And with this, we can just go ahead and copy and paste and run the program, and you can do that, okay? So my job is not to copy and paste the code and actually run the program, because you can obviously do it yourself as well. Is to explain, how it works, because you can run it through, but but how does it work? So with question number 1, you might notice the first main difference is it is now having 2% C instead of 1 single %C. Okay, that's the first major difference between this and the practice exam. And because it has 2% Cs, I have to give it 2 addresses of 2 characters in order to, so you'll be basically reading 2 characters at a time, or try to read 2 characters at a time, okay? But if you look at the condition, it is an equal to, which means if it is not reading in 2 characters, I'm getting out of this loop. Now this is the main difference. This is a really important part, because it means if it's reading only 1 character, because there's only 1 left in the file, it's going to get out. If the file has ended already, it's reading -1, it is going to get out, okay? When you look at your student ID, how many digits do you have? It has 7 digits, okay? So with 7 digits, the first read will read the first 2, the second read will read the third and the fourth, and then the third read is going to read the 5th and the 6th. The 4th read will fail this condition, because it will only be able to read 1 character out of the 2 that scanf is requesting. So the return value of scanf is going to be a 1, which means it doesn't go into the body of the loop, and it will basically just get out of the loop. All right, so that means you only go through 3 iterations. This line only executes exactly 3 times. Every time it runs, you are going to evaluate ch1 minus 0x30, which is the ASCII code of 0, and plus, and then the whole thing is typecasted in integer. In other words, this part here is still of a char type, but this is now casted to an integer. And a lot of people ask, well, what about the other part? Okay, but during the test, I cannot answer that question. The answer is, when you have addition, if you remember from coercion, okay, this is a really, really early topic in this semester. If one side is an integer, the other side is a character which is shorter, it will automatically change the other side to match the same size as the longer or the bigger side. That's done automatically. We talked about coercion, early. It's one of the operators that we talked about. Is actually I can point out where it is. If you guys need to check the notes. Oh, wrong class. So it is in, let me find the topic here. So it's in operators. When we talked about casting, coercion, that's one of the topics that we talked about. Typecasting, coercion, and this is actually coercion because it is implicit. And in this one, we only use the assignment operator, but it operates in the same way. If you look at this one here, there's a coercion forced already. So that's This one is clearly the other one too. If you look at this example here, x itself is just a 32-bit integer, but because I only cast one side, it forces the other side to also get into the 64-bit representation, so that the whole thing is going to be 64-bit times 64-bit.
What about the y? Is the y converted as well?
Well, once you have a 64-bit dividend and you have a 32-bit divisor, the divisor will also be automatically converted to 64-bit before a 64-bit division happens. In fact, that might be explained down here too. Yep, there we go. So this whole thing, kind of has been explained. I know, we might not have really talked about it explicitly this time, but it is there. All right. So what it's going to do is to look at. It will give you the digit of the value of the digit of the first character, and add it to the value of the digit of the second character, and then it will print out the sum. So it all depends on what your actual student ID is. There's no one single answer for this one because it all depends on your actual student ID. Are there any questions about this one? Do you guys want to see it run? I mean, you can actually copy and paste it and make it go. So we'll go ahead and copy.
Just do like an example student ID, or
huh?
We just do like an example.
Yeah, sure. I can do that. So I'll copy this into q1.cpp. Paste g++1all-g-o, just in case. I don't really think that I need to use a -g, but just in case I need it. Okay, so when you look at the actual description of the program and the input to it, assume a file called id.txt contains your student ID in text. Okay, so it's not a binary file, it is just a regular text file. The 7 digits and nothing else, not even a line feed at the end, is going to be the only content of this file. So what that means is I'm going to create a file. We'll call it id.txt, just like in the question, and I'm going to use a sample student ID. I hope this doesn't actually match the ID of someone in this class. It's unlikely. Okay, I'm only going to give it 6 digits because I have to hack the 7th digit in by using a program called hex edit, which is not installed. That's fine. We'll go ahead and install it now. Oh, cannot spell. Install hex edit.
What does hex edit do?
It's a hex editor. It's a hexadecimal editor. Because we don't want that line feed. We want to get rid of the line feed character. And this is kind of you can do it probably in Nano too. Nano does not automatically append a line feed character. Well, in fact, let's go ahead and check with Nano first. Nano id.txt, and we'll just append a 7 here without a line feed. No, it has a line feed already. There's no way to get rid of that extra line feed. We'll see whether we can do it. Hex dump-c.txt. Yeah, see, it has this extra line feed character, which I don't want. Okay, so let's see if I can get rid of it using VI. So there's no way to actually get rid of it. You have to create a file with only 6 characters and then a line feed character, and then use hex edit id.txt. and then go to this location and actually change it to 3.7, and then we can exit the file. And now, when we look at the hex dump, the actual content of the file, it only consists of the 7 characters that we want. Okay. All right. So the question now is, what happens when Q1 is run and we use id.txt, which does not have a line feed character, to get into it, the end result is 476. The 4 comes from 1 adding to 3. The 7 is 2 plus 5, and then the 6 is 0 plus 6.
It's not displaying it.
Yeah, you can't see it on ours. We can't see it on the display.
Oh, sorry. I need to adjust the monitor.
But it came out blank. I was like,
Are you
oh
guys
no,
telling
I
me
do
that you cannot
apologize.
read my mind and see what I'm actually seeing? We are all in big trouble if you guys can read my mind. For many, many reasons.
Start asking different questions for the test.
But then I can give you like wrong answers. Project the wrong answers. Maybe. Okay, so are there any questions about the output of this program? For each and every single question, there's partial credit. In other words, if you get the first number right, but not the second or the third, you get some partial credit. If you get the first two right, but not the third one, you get some partial credit. If you get all three right, obviously you get a perfect answer. If you have anything other than 3 lines or 3 output, then you get your partial credit again, because that would not be the actual behavior of this program. So are there any questions? Yep.
Can you just run through how you just get the first number, like 4?
Sorry?
Can you run through the program?
Yes, the 4 is coming from the 1, 3. But if you want to run it through GDB, you can actually do it too. So when you run it through GDB, you want to set up a breakpoint. I would set a breakpoint at line 8, and then we'll run it with redirection from id.txt. And this is the first time. So when you break it the first time, you can print ch1, which is the first character. You can print ch2, which is the second character. The ASCII code is 49 for the first character for digit 1, and 51 for digit 3. 30 is in hexadecimal is 48. 49 minus 48 is 1, so this is 1 here. This is 51, this is 48. 51 minus 48 is 3. So you basically end up with 1 plus 3. And 1 plus 3 doesn't matter whether it's actually integer or char, which is a shorter type of integer, it is still 4. That's why when you print, when you're printing the value of this entire expression, it is just printing 4 in this case. Is that okay?
Yeah, I guess that's fine.
You can even do something like this. I mean, you can even say print and then just copy and paste this entire expression, and it will still give you the same answer.
Like, how would you have known, like, the ASCII code of, like, 1 is 49?
Because I
Question.
put it here. The ASCII code of 0 is 30 in hexadecimal,
Okay.
48 in decimal, and 060 in octal.
See, so,
And they're all sequential. This question actually resembles the practice question quite a bit, except for the %C part, which is the only twist I put into the exam question. Okay. Is that okay so far? All right. Moving on to the next one. This is question number 2. You guys are missing all the fun stuff because I actually used the happy face and tongue sticking out, face. But all you could see are the squares because the printer does not have the font for the happy face and the tongue stuck out face. But basically, for this question, well, okay, let's take a look at function f first. Okay, I have to look at the screen because it extends below, the monitors of the front row, so you can't really see the entire thing. All right, so the only problem with this one is I forgot to, put this part up here, but I, put it on the whiteboard, and as a result, no one should really miss it. All right. So the question is this a recursive subroutine? And the answer is, it is recursive, because the function f has a potential of calling itself. Now, it doesn't have to do it all the time. As long as there is a potential, it is recursive. Okay. And the way it works is, if x is greater than y, greater than or equal to y, then it does not do it recursively. It just computes x plus y. It's all done. Okay. So the only time it is recursive is when x is actually less than y. Then it will call itself again, but it will flip the y and the x. So in the recursive call, it's not going to call itself again. because if x is less than y, then y is greater than x, so the next time it calls itself, it's guaranteed not to call itself again. So the recursion cannot be endless. Is that okay so far? So for each invocation, I have a printf at the beginning. I want to show what is the x and the y of this particular call, and then we perform the actual calculation here. And then we have another printf here to show that for this particular invocation, the result R is the following value before it actually returns. Do we have any questions about this part? So when you look at the main program says it will only use the first and the last and the second last digit of your student ID, and it will do the first one is just calling xy in the order of x and y, and then the other one is to call xy but in a reversed order, and I'm not going to add the return value of the first one and the return value of the second one, because in the second one I have a compound assignment. It is not a simple assignment, so it will add the second one to the first one. But at that time, x would have changed already. That's the trick, okay? The tricky part is the first call of f, the value of the first call is stored in x already. So the second time you call the subroutine, this is already changed. So you have to kind of take that into consideration as well. Are there any questions about this one? Yep.
Why do you initialize the z?
Why do I?
I was wondering, the z on there, you have x, y, z initialized.
Oh, it's just sitting there doing nothing.
I looked at the thing for a while, like, where is the z?
No, I just left it there because it doesn't do a single thing, and you should have ignored it. You can just ignore the z and go like, yeah, okay, we're not using it at all, and just leave it alone. Or you can comment and say that the z is declared but not used. But it's not an error.
Yeah.
It would generate a warning. The compiler would have complained and say, hey, you declared this variable but you're not using it. Are you sure this is what you want to do? Okay. Are there any questions about this one so far? Do you guys want to run it with an example, or? Yeah. Okay. So give me a sample. Okay, what do you want to be in x and what do you want to be in y? Just give me what is the happy face. Tell me what you want to be the happy face and what you want to be the tongue stuck out face. Huh?
1 and 3.
1 and 3. Okay, so let's try the 1 and 3. Okay, so if you replace it with 1 and 3, this is going to be 1, this is going to be a 3. Is that okay? So when you call f the first time, it will get here. So the first line it's going to print out is x is 1, y is 3. Okay, that's pretty simple. And then we'll get to this line here. When it gets to this line, it will say, okay, x is 1, y is 3, 1 is greater than 3, 1 is greater than or equal to 3 is false, which means it's going to go for the else value, which is here. So it's going to call itself again, except it reverses the order. So now it's y which is 3, and then x is 1. So when you get into the second invocation of f, in the second invocation, x is 3, y is 1. And it will print x equals to 3, y equals to 1. That will be the second line of output. So the first line of output is x equals to 1, y equals to 3. The second line is x equals 3, y equals to 1. But since x is 3, y is 1, x is greater than or equal to 1 is true, so I just perform the addition here, which is 4, and I will store the 4 into R. This is the third line of the output, which is R equals to 4. Then we'll go to return. But where is this returning to?
Where it calls it right
It
there.
returns to it will return to this part of the to the first invocation of f. So this becomes 4. 4 plus 1 is 5, and that is what I store into R. R equals to 5 is going to be the fourth line of output of this program. Okay, and so R, which has a value of 4, is going to be returned. And when it returns, it will get back to here. This becomes 5. X is now updated to 5. Y is not changed. So by the time we get to this line here, it will print x equals to 5. Is that okay? When we get to here, x is already 5, y is still the same as before, which was 3. So it'll be 3 and 5 here. The first call to f is going to have parameter x being 3, parameter y being 5. So it will print this line as x equals 3, y equals 5. 3 is greater than or equal to 5 is false, which means we are now going to reevaluate the recursive call. When this is called again, y and x are reversed. So in the second invocation, x is parameter x has a value of 5, parameter y has a value of 3. It will print x equals 5, y equals to 3. Since 5 is greater than or equal to 3, we'll just be adding those two. It becomes 8. And it will print r equals to 8. Then we'll actually do the return. The return from the second invocation of f goes back to the first invocation of f, which is down here. So this becomes 8. 8 plus 1 is 9. This whole expression is 9. R is now updated to a value of 9. It will print r equals 9. R is now returned. It will go all the way back to the main program, going back to here. This is now 9. But I'm not just assigning 9 to x, I'm adding 9 to what x already has. Now this x is a local variable x in main, which had a value of 5. 5 plus 9 is 14, and this line will now print x equals to 19. 14, sorry. Yep.
Say that we put all of our print statements along the line of the print statement instead of where we're supposed to put it.
But then it will be confusing because we are getting to this, we will be getting to this line 4 times. And the same thing with this line, it will be here 4 times as well. So I will not be able to tell, how these prints interleave with these prints here. So that will make my job very hard because as much as I don't want to take all the points away, it makes it kind of difficult to determine, okay, but how are these things, interleaving? So I'll have to come up with a way to assign partial credit in that case. So you guys think of things that I cannot think of. I really thought of the whole thing, go like, okay, this is an easy way for me to grade it. I can assign partial credit. So if you guys get it right the first few times, you will still get partial credit. For some people, they can track the recursion going in, but not coming out. So at least they'll be getting partial credit going in, and when they back out, maybe they are not, getting everything right. Well, there will be at least some partial credit. But you just mentioned something that I did not account for.
Professor?
Yep.
So for a problem like this, would the partial credit be like 10 for the first part, 10 for the second part, or like?
I have not decided yet.
Okay.
It may or may not be even.
Okay.
Yep. Ultimately, the grade is still going back to what we talked about, in the first class. If you scale everything back to 0, 1, 2, 3, 4, 0 is F, A is 4, A is 4, and and each grade represents what I think is, well, 0 is an easy one. It's either no answer was turned in or it's completely wrong. A is an easy one. It's a perfect answer. Cannot get any better, right? So in between we have B, C, and D, and that will still be going back to the syllabus of what I think should be a B, what I think should be a C, and what I think should be a D. Yep. Alrighty. Are there any questions about this one? Are you guys just going to take my words for it? Of course not. Since we have the computer right here, well, let's go ahead and try it out. So this is question number 2, and we'll just paste it. G++.
Smiley faces work there. So the smiley faces at least work there.
Oh yeah, I cannot. Well, let's see what the G++ has to complain about this. Well, let's see what it has to say about it. And I'm kind of surprised that even that one pasted. Well, it doesn't mean that it's going to work, but
Yeah, that won't work in
it's
the
not going to
right
work, but I want to see how it's going to complain about it. Well, it says expected primary expression before the semicolon. Oh, because I'm missing a semicolon here.
It's inside of the face.
No, the semicolon is here.
Yeah.
So the smiley face is interfering with the compiler into thinking it is at a different location. All right, well, let's find out what it looks like in the actual program. This is q2.cpp. Actually kept this here too. It's a double byte character. That's why it's messing up the compiler. The compiler cannot deal with double byte characters, and as a result, it's getting confused. We wanted to have 1 and 3, right? That's what we wanted. I'm going to get rid of that too, just in case the compiler wants to complain about that. Yep, it complains about Z being unused, but that's okay. You know, we know that one. And we'll just go ahead and run it. Q2. So print x equals 1, y equals 3, x equals 3, y equals 1, r is 4, r is 5, x is 5, x is 3, y is 5, x is 5, y is 3, r is 8, r is 9, and then x is 14. So if you roll back the tape, you know, for those of you who are watching it right now, you would hopefully you remember what I just how I explained it, and this is exactly the way that I explained it. So for this one, you know, obviously, you know, I think anyone who can get the entire sequence will get an A, because you know it really reflects a complete understanding of all the material about, you know, subroutine calls, and be careful enough to get it done. A B would basically be people who basically get the idea, but then, you know, somewhere along the line, you know, made a mistake, okay, calculation mistake, or forgetting to do certain things. But otherwise, it can prove to me that the concept was understood. A C is kind of like, well, you know, maybe the concept was not well understood, maybe not the recursive part or something. A D means, you know, it's not really sufficient, okay, you know, not sufficient to get a passing grade for this particular question, not for the entire exam, you know, just for this question. There are 5 questions in all. Okay, moving on to the next one. Question number 3. Question number 3 has a, you know, smiley face with sunglasses. Okay, this one is, I thought about, you know, how to ask questions about this one, because, you know, I already gave you the swap code. So I decided, hey, you know, we'll just kind of, you know, use the correct swap code, because when you look at the actual swap sequence, this is the correct sequence using the dereference at the right places too. And I have the extra printf here just so that, you know, you can tell me what you know about, you know, what px points to, what py points to before the swap operation, and what do you think they point to after the swap operation. But all of this stuff is actually somewhat pointless, no pun intended, because when you look at, you know, the way I call swap, I'm passing, you know, the address of I twice. In other words, px is an address of I, py is an address of I as well. So what doesn't matter which one you print, they are the same thing. So in this case, it will just be printing the original value of I a whole bunch of times. Are we doing okay so far? Now, trust me, I'm not really trying to be tricky here, because otherwise I would not have said this. And put a winky eye next to it too. Is that okay so far? So it doesn't matter what it is. I mean, you know, this just has to be the rightmost digit of your student ID. Let's say it's 5, okay? So what the program is going to do is it will print 5 and 8 here, but it will also print 5 and 8 here. In the subroutine, it's going to print 5, 5. It's going to print 5, 5 again here, because both pointers are pointing to exactly the same place. Are we doing okay so far with this one?
I think I didn't see the top 2 printfs.
Huh?
I think I only did the bottom 2 printfs. I didn't see the top 2.
You just made an assumption. Okay. So that would be a B kind of grade, because if you indicate here that nothing happened to the variables,
Yeah, have that bottom one. So
then it suggests to me that you understood that we are not actually swapping anything, but you're missing something in the actual output. And here's question number 4. Do you guys want me to see the program run? I mean, this one is no. Okay.
So if I equals 1, and if I equals 1, then the answer would be I equals 1, K equals 4.
Yeah. Yeah. I equals 1, K equals 4, and then it will. But in the swap subroutine,
Yeah.
it will just be printing 1, 1, and then 1, 1 again.
So you have to write the output of that subroutine?
Yeah. Yeah. Well, because it's in the subroutine. I mean, when you
Yeah, it's still
What if you just write down in words like it swaps itself so it stays the same? I thought you just needed to find
But that's not what the question is asking. See, the question says you write down the output of this program, not explain how it works, right?
Now that I notice those there, I know how it works. I just
Well, those are put into there explicitly just so that you can show me,
yeah.
what you know about the parameters when the subroutine is called. All right, question number 4. This is the long one, and this is the one that has the PTO, at the end. So this one has, main doing this, and this is the subroutine. So we'll focus on the subroutine first, okay? So the subroutine has it's called sum, which is kind of, it is what it does, okay? Except, there's a little twist to it. It takes one parameter, which is a pointer to an integer, and it has a return type of an integer as well. But it's not returning the sum itself, okay? What it is returning is the result of the scanf. That is what it's returning. The sum is actually put into whatever PR points to. Whatever PR points to is incremented. Oops, sorry, let me scroll up. Is incremented by this value here. So let's take a look at this loop here and figure out what it does. Now this is a while loop, and the condition to stay in the loop is this is a not. Okay, somebody asked me, are we missing something here? And the answer is no, it's not missing anything. Now the reason why it's not missing anything is, okay, we have to evaluate from the inside out, right? Okay, so let's go ahead and do it. X is an integer, Y is an integer. X has an address, Y has an address. And you need to supply the address to a scanf. In this case, the scanf is the same as the one in the practice exam, which is it is looking for a signed integer, comma, another signed integer. That's what it's looking for. That's what the %d means. Okay. And even this part is the same. Okay, I'm taking the return value of scanf and store that into R. But the assignment operator also has a value. The expression has a value, which is exactly what scanf is in this case. In this case, scanf, which is the same as in the practice question, okay, I'm asking it to read 2 things. So the possible return values will be 2 if it can read both integers successfully. It can return 1 if it can read the first one, but then there's no second integer to read. Or it can return 0 when there's no integer to read at all. Okay, there's something in the file, but it does not fit the description of an integer. Or it can return a -1 when we're at end of file. Those are the 4 possible values they can store into R. In this case, how am I going to stay in the loop? As long as R is returning a 0. Okay? In other words, as long as it's not even reading a single integer, but not at end of file. Because when it's at end of file, it's -1, is -1 0? Well, if -1 is not 0, it is considered true in this case. Are we doing okay so far? Okay. So what I do in the loop is the same thing as in the practice question, which is to use a local variable ch and just toss away the character that is interfering with reading 2 integers. And I will keep doing this until we can read at least 1 integer or end of file. This part is also new to this to this particular question. The practice question did not have this part. This basically says, if I did read at least 1 integer, I want to add something to whatever PR points to. So this is a ternary operator. This is the expression that evaluates to either true or false. if I just read one single integer into x, I'm just going to add x to whatever PR points to. On the other hand, if r does not equal to 1, which can only mean I have read 2 or nothing, okay, then I'm going to add both of them to whatever PR points to. Are we still doing okay so far with this? Now, can I be adding something that is not initialized? Because it seems like when r equals to -1, I'll still be adding x and y, which in that case will be uninitialized. But look at how I can get into this code here. R has to be greater than or equal to 1 to begin with. So when r equals to 0, I don't even bother to update whatever PR points to. Is that okay? All right. So the main program is actually quite simple. All it's going to say is keep doing this until sum is no longer greater than or equal to 0. Well, sum can be -1, 0, 1, or 2, right? It can return those values. The only time it's not going to be greater than or equal to 1 is when we hit end of file. Then it will just be returning a -1, and that will get me out of this loop. But for all other cases, it will get into, quote unquote, into the loop, and then the only thing I do is to print out, okay, tell me what is x at this point. That's what this statement is about. Okay, so every time x should be increasing a little bit because of the code here, unless your student ID has a lot of zeros. Are we still doing okay so far? So let's go ahead and check out what this is going to do. We'll use exactly this sample case here. So the first time we call sum in the first iteration, it will start with this lowercase a character. Can I interpret a as a signed integer? Nope. So we get into the loop, do the scanf with a %c, get rid of the a. And then in the second iteration, when I ask it to read an integer, a comma, and then another integer, it will read the 65 successfully. It will parse the r darn it. It will parse the comma successfully, and then it will fail to interpret the second integer because it's an r. So at that point, scanf is going to return 1 because it was able to read one of the two things that I asked it to read, right? So that means the loop inside sum is going to exit because it has a value of 1. And then I'm going to add 65 in this case to x in the main to the main program. So main is going to have 65. Okay, x in main is going to be 65. So just keeping track of the assignment here. Then I'm going to call sum again. When I call sum again, this is the first read. It is an r. I'm asking, hey, give me two integers separated by a comma. Scanf says, nope, cannot do it because it is starting off with a non-integer thing. So I will go into the loop in the sum subroutine. It will get rid of the r, and in the second iteration, it will read in the 10, the comma, and the 3, and this time it returns a 2. Scanf returns 2 because I actually do have two integers in this case. Is that okay? 2 is non-zero, which means it is true. We get out of the loop from sum. We get into the conditional statement. The conditional statement says, oh, let me add up 10 and 3, which is 13, and then use 13 to add to whatever PR points to, which is x. So at that point, x is going to be updated to 65 plus 13, which is 78. We return from sum, okay? And when we print, x equals to 78 is the second print or the second output of this program. The third time we call sum, it will start with a c, which will fail because that is not the beginning of any integer, which means if scanf returns a 0, I go into the loop, it will get rid of the c, then it will read the d, same thing happens. D cannot be the beginning of an integer, then we'll go to the exclamation point, which cannot be the beginning of an integer either, and eventually it will get to the 8, comma 2. Okay, Okay? In other words, it will look at 8, 2 as one thing, and it says, hey, you asked me to read an integer, a comma, and another integer. It's all successful. Scanf returns a 2. I get out of the loop in sum. In the conditional statement in sum, r is greater than or equal to 1, and so we will add up 8 and 2, which is 10, and then we use 10 to add to whatever PR points to, which is x. So x will be updated again to 88. But we're not going to print it out until we get back into the main function. But when we get back into the main function, sum returns a 2. So we get to the print statement in the main function. It prints x equals to 88. It goes back to sum again, but this time there's nothing left in the file because there's nothing else, right? When we're at the end of file, it's going to say scanf returns a -1, and the -1 will indicate to main to exit the loop in main, because when you look at this one here, we only stay in this loop as long as sum returns something that is greater than or equal to 0. When sum returns a -1, it indicates it's the end of file. So we get out of the while loop, we get to return 0 in main, and we're all done. Okay, so are you guys taking my words for it? No, of course not. I mean, not with this kind of complicated stuff. So let's go ahead and copy and paste the program and see it run. I don't know about your other professors, okay, but at least with my classes, you always say, okay, let's double check, make sure. And this one is question number 4, Q4 CPP. Paste. Okay, and we'll go ahead and create a file. Okay, so we'll use another cat to create a file. Q4 test.in, and we use exactly this test case too, because we just talked about this one. And go back here, do another paste, and then we can run Q4 with a redirection of Q4 test. In.
Well, I have like a kind of basic question. Like, I don't understand why it keeps going back into the loop after it leaves.
Keep going back into where?
Into the loop. So like the first time.
Okay, but which loop? There are 2 loops. One loop is in main.
The one with the negation.
In.
The separate. That one. Yeah.
This
So-
basically is the same thing as saying, as long as R is 0, keep doing this.
Mhm. But like when it reads it once.
Then get out. Get out. But it only gets out of this loop. Main is going to call it again because main it has its own while loop.
Okay. Right.
All right, so let's check this out. Does it match? Yep, it does match what we have on the whiteboard. But for these programs, just looking at this result is not enough. Okay, you really need to go into GDB and find out, how it works, when you're in GDB. Are there any questions about this one?
Almost tough.
Well, it takes a little bit of time to process it. Yep. But it's still a derivation of the exam in the practice test. The format string is the same. Yep.
It asks, does the program exit?
Does the program exit? Now that's a good question. Okay, so assume when we run the program, we supply the following as an input line. When you feed it the file, it does exit, but if you interactively do it on the keyboard and you don't type Control-D, then it does not exit. So I suppose I would take both yes and no as answered in this case. Because it's not specific. I should have said, does the program exit when it's reading from a file? Then the answer is yes, it will definitely exit at some point. But if you're interactively doing it until you type Control-D, it's not going to exit. So I'm going to ignore the answer to this part.
Or you could give us partial credit for either one.
for either one. Partial credit for either one.
There's no
Yep.
way to get.
So it looked to me like it stayed in the while loop of main forever.
No,
because
it won't.
X never-
It's not going to stay in this loop forever because when you're reading from a file, eventually it will end
Because end of line.
because of end of file. It has to do with end of file and not so much with end of line. End of line is kind of like a space character as far as scanning for an integer is concerned. So when it gets to the end of line, it doesn't really bother scanf. But when you get to end of file, then scanf returns a -1. That -1 stores into R. R gets returned, and then in the main subroutine, when sum is returning any value that is less than 0, it gets out of the loop. So technically speaking, it does exit at the end of a file. Okay, but since I did not specifically ask, okay, does it exit when you feed it a file that is already pre-made, like redirecting the file? So potentially, it does not exit.
But R can never equal 0, right? Or it's I mean, I'm sorry, not R, but the sum right there, that'll never be.
That is correct. It cannot be 0 because if it's 0, we're not getting out of the loop.
So essentially,
in
the only
loop
way you
here.
can exit is a forced exit, or like that. You like the Control D or the like you said, the end of file.
Well, Control D is not a forced exit. Control D means end of line as far as the standard input file is concerned.
But if at that point R would equal
-1. Correct.
Oh, that says less than 0. That's
Right.
Okay.
So, but because I did not ask the question, in a very specific way, I cannot, hold you guys accountable to either of the answers.
Partial credit either way.
Full credit either way. I think.
I like these anonymous dolphin, grizzly, hedgehog, and koala. That's you guys, okay? There are 4 people in class actually doing it right now. All right, so that's question number 4, and here's question number 5. As far as question number 5 is concerned, it is based on the practice test. It just has a little spin to it, okay? So the spin to it is we're assuming the input is your student ID with 1 digit on each and every single line. So the first scanf is going to read the first digit, the second scanf is going to read the second digit, and so on. And this is what we do with after we scan an integer into a bracket 0. And can someone tell me exactly what this is going to do? For instance, if your student ID starts with a 9, what is this going to do with a bracket 0?
It's going to divide 9 by a size, which is 5.
Right.
And then whatever the remainder is going to go into a bracket 0.
Correct. And in this case, the remainder is 4. 9 divided by 5 has a remainder of 4. So that's what the percent equal to is going to do. So in the loop here, I'm going to read an integer into a bracket I, and I starts from 1 in this case, okay? So you have to be careful because a bracket 0 is done already, okay? So that's why we are starting with a bracket 1. So you have to, then you have to perform this calculation. So this calculation is based on what you just read, plus a bracket I minus 1, which is the value of the previous element, plus the prime number, which is still 7. You take this entire sum and then you divide it by a size, and you take the remainder and put it back into a bracket I. After all this calculation, you tell me what is the current index number, and then you tell me what is the value at that particular index in the array. When this is all done, I want you to tell me what is at a bracket 2, and what is at a bracket 2, and what is at a bracket 2. Okay, so this one, in the original idea, I only had this line without the other 2. Then I thought, well, maybe that's a little brutal. So I added the other 2 lines to kind of help you, think about how to process the third line. Because if without the first 2 lines, it is a little bit brutal, okay? So it's like, oh, but how do we deal with, a bracket 2, and then close brackets 3 times, all in the same, in a row. But using this particular way, then you can say, oh, a bracket 2 is just this value. Well, is that value a valid index into the array? Yes, it is, because I made sure by using division by 5 at the remainder of division by 5, so it's guaranteed that every single element is going from 0 to 4. So A bracket 2 is just taking whatever the value from the previous line is, use it as an index, and get to me the value of the other element, potentially the other element. And then the third line is kind of doing the same thing. Just look at the previous line and go like, oh, okay, I know what is A bracket 2, close bracket, close bracket. Now we take that value as an index and use it to index into array A again and tell me what is the value of the element. So I'm hoping with the additional printf, nested 0 and nested 1, nested 2 becomes more manageable, because you can actually see how the brackets unroll by themselves. Okay. Are there any questions about number 5? And then somebody asked me, but my student ID has 7 digits. What is this program going to do? It doesn't seem to work. Well, what do you think this program is going to do?
Disregard the other numbers.
Yep, it'll just ignore the last 2 numbers. Because the loop only goes through 4 times. So combined with the first scanf, which is not in the loop at all, it will only call scanf exactly 5 times. So it will process the first 5 digits of the student ID and leave the last 2 basically unprocessed, just ignoring. Yep.
But it's not going to take in 0, right?
Say again?
It's not going to take in the first digit?
It will take in the first digit. The first digit is read by this scanf, and it will be stored into the first element of the entire array.
Yes, but printf.
It will not print it. That is correct. It's not printed. Now, but you might still end up printing it in the nested ones. It all depends on the values of your other digits. So there's still a potential that you need to go back to it. Yep.
I'm not positive I did it correctly, but my nested 2 ended up as a 5.
Your nested 2 has
an
a
A of 5, and 5 was never scanned. So I just put garbage.
But why would you end up with a 5 in
I
it?
think it was
That is strange.
1 modulus 5.
But anything mod 5 can only go from 0 to 4.
So if you have a remainder of 5, then it would just be.
It will be a part of the quotient. You're
Yeah,
just
it'd be
adding
not
1 to
part
the
of the
quotient.
So 1 modulus 5 is 4.
Okay, so let's take a look. 1 divided by 5. What is the quotient?
0.
Quotient is 0, and then the remainder is
1.
the dividend itself, which is 1 in this case. Because the mod operator is basically taking the remainder of a division.
Yeah, I think the most difficult part of this question is remembering how to do remainders.
Well, remainder is a very important concept, because everything that we do in computer science, in actual programming, we are already dealing with only the remainder. It's just that the divisor is 2 to the power of 32 or 2 to the power of 64. But if you only have the last line, done a little bit wrong, you're still gonna get partial credit for it. I try to structure the test so that there's partial credit in everything. All right. Are there any questions about this whole test? Is it better than the previous one or worse?
This was harder.
Yeah.
It is harder.
This is really hard, yeah. Or it's more like just a lot to carry on each question, like each thing.
Right,
like
because it's
lot
a
of stuff to-
combination of things that you may not have seen before.
Well, that and just like
Just the
some of them are
time.
just so long that you have to write down so
Right,
much.
you
that
have
doesn't
to
actually
track
print,
it.
and then
Exactly.
track
Yep.
it was
You have to track it.
the toughest
And in
part.
this class, I do not talk about how to track the execution of a program. I did it in cisp360. Some people, well, they're only like, did you come from my P300? Okay. So you kind of know how to track it, using a spreadsheet, but you can always use a short form of that, to track the execution of a program. But if you did not take P300 from me, I'm not really sure whether the previous professor talked about how to track the execution of a program. So you might have to come up with your own way of tracking it, basically.
Yeah, that's what I was doing, but
But a few people left like within half an hour of the test.
I think that wasn't like a finish the test and I'm out of here.
I don't know. I mean,
Like,
some of those students seem
I have
pretty
no clue
happy.
what Tag is talking about. I'm out of here.
So
Yeah.
can we put in like a sample student ID for this problem and see what that
Absolutely, absolutely.
Is there an actual is this doing anything, or it's literally just to get numbers out of it? Like, is there something?
Yeah,
that this
it's
is
just
actually...
get some number out of your ID. You can probably use it to generate like a password of your ID based on your ID, or something like that. I wouldn't use it for any really application that requires high strength encryption. All right, so let's take a look. G++ dash wall dash G dash O Q5. And what ID do you want to give it?
1, 2, 3, 4, 5, 6, 7.
Okay.
Or that one.
Or that one? Okay. So we're going to have to use a new line for each digit. Like so. And we'll run Q5 with id.txt as input. That's what it does. Okay, let's see whether it makes sense or not. Okay, so let's go ahead and check out what is in id.txt. Okay, so now we can actually see the input and the output at the same time. Okay. The first one being 1, okay, let's check whether that makes sense or not. We know this 1 is going into a bracket 0, but the value of a bracket 0 is never printed, okay, because that's not a part of the loop, and as a result, it's never printed. The next one is a 3. So we add 3 to 1. Okay, first of all, the 1 has to be modded with 5 first. What is 1 mod 5? 1 mod 5 is
1.
just 1. Okay, yeah. And so it's not really affected. Okay, it only affects the number when it is more than or equal to 5. Okay, if it's greater than or equal to 5, then it wraps it around back to a value from 0 to 4. Okay. So the second number is 3. And we will add it to 1, and then add 7, which is prime number, right? So 3 plus 7 is 10, 10 plus 1 is 11. We store the 11 back to a bracket 1 first. But then before the print statement, we use the mod operation, so we have 11 mod 5. The remainder of 11 divided by 5 is 1, and we store that 1 into the second element of the array, and it is printed as 1:1. Okay, so that part is okay. Then we read the 2. So we read the 2, we add it to 1. 2 plus 1 is 3. And then we add prime to it, which is 7. Okay, 3 plus 7 is 10. We store the 10 into a bracket 2, but then we perform the mod operation. 10 mod 5 is 0. We store the 0 into a bracket 2, then we print it out. It has 2:0, and that's correct as well. Then we read the 5, we add it to the previous array element, which has a value of 0. So that gives us 5, and then 5 plus 10 is, 5 plus 7. Okay, 5 plus 7 is 12. 12 mod 5 is 2. And that's why I print 3:2, because the fourth element has a value of 2. And then read the last digit. In this case, it is a 0. 0 plus 2 is 2. 2 plus 7 is 9. 9 mod 5 is 4. And that's why I store the 4 into a bracket 4. That's why we have a 4:4. Okay. And then the output, the first one is nested 0, which is just a bracket 2. And if you just look at the output, you can see that a bracket 2 is 0. And then the second one is a bracket, a open bracket 2, and then close bracket, close bracket. We have to evaluate from the inside out. So a bracket 2 evaluates to just 0, But a bracket 0 has a value of 1 in this case, and that's why it prints 1 as a result here. And then the third line, which is nested 2, is basically just a bracket 1, taking the previous line. A bracket 1 has a value of 1, and so it doesn't change. Yep.
I would be happy if I had put all my outputs in the right spot.
Did you? But you kind of scatter it.
It's all right next to the print statement. So
It's all next to the print statement.
I didn't put
Did you
it
get the
in.
right thing though? I mean, did you get the right values?
Okay. Also the question, but it's all not what it's supposed to be.
Ah.
It's okay.
I kind of, thought about this, and I thought that, some people might not put it in the right order, and that's why in here I even kind of mention it. Okay, when you write the output of a program, write in the correct sequence in the usual standard of left to right on a line and top down across lines. So I was trying my best to kind of remind you guys to, okay, do it in a way that I can see the actual sequencing of the output. So I will have to think about how to grade yours. I did not account for.
I'm just happy that I somewhat understood it. Should have
Okay.
more time to read clearly.
Alrighty. Would you guys prefer to have a different type of question for the final exam in the form of open-ended question? And I'll let you guys use G++ and GDB in the process. So the question will now be in the form of, this is what I want your program to do. Write a program to do this.
No.
I'll take it.
It's anything like when we're writing a program.
Or worse yet, I've learned the hard way that this is actually worse when I was thinking it's better, but most students told me it's actually worse, which is in the form of, here's my program to do X, Y, and Z. Modify this program so it will do X, Y, Z, and W. That turned out to be more difficult than just writing a program from scratch, because now they have to understand the structure of my code first, and then figure out how to change it to also do W in addition to X, Y, and Z.
How about something like A for effort?
That would make my job easier too. Then I should be just teaching online classes. Alrighty. But is that okay? Do you guys still remember the breakpoints of the grades? 60% for D, 70% for C, and so on. No, you guys still remember, right? How I break down the grades into A, B, C, D, F? Yep.
So this here says the exam counts for 20% of your total grade?
Yes.
And then on the grades sheet it just says 20 points.
Correct. So in the grade sheet, what I do is I scale everything to the percentage. So when you see 20 points, it means 20 out of 100 points of the entire class, of the entire semester.
Because some of the homework assignments, I mean, if you total them all, they're way more than 100.
But all the homework assignments only add up to 20%.
I see.
So all the homework assignments is, okay, so the way it works is you have 100% for your actual final grade. Is broken up into 4 categories. So one category would be all the homework assignments. So all the homework assignments only add up to 20% to the actual pot, okay, the actual main pot. Then we have exam 1, which is 20%, and then we have this particular exam, which is exam 2, which is also 20%, and then we have the final exam, which is 40%. So at this point, we have filled up this one here. This is to be graded, and then we have the majority of this being done, not entirely, okay? So you have basically around, I would say, somewhere between 45 to 50% of your grade is to be determined, which is a good chunk of a percentage, actually. Yep.
probably kind of early to be asking this, but is our final going to be formatted like this test where it's a bunch of programs and we trace them, or like half like the first test and this test where you give us like a line and say what's the output of this line? You know how the first.
I think it's going to be closer to the exam 2 than exam 1, because I will need to test, it's comprehensive. So, it's pretty hard for a programming class not to be comprehensive, to only focus on one thing or another. But it'll be focusing mostly on stuff, that is after the second exam. So it will be mostly the material that we'll start to talk about, but including structures, because you might have noticed exam 2 does not have any questions on structures. So there will definitely be questions on structures in the final exam. Okay. Any other questions?
Is it going to be a written one like this, or are we going to do it aloud?
It'll be like this, just write down the output. Because I have to kind of decide, whether you have access to G++ and GDB, so you can actually run the program. But in that case, it's pointless to ask questions of this kind, because people can just kind of run it through and find out what is the output. So it's either this, or I can give you access to G++ and GDB, and then it becomes a programming type of question, open-ended, kind of like a homework assignment-ish, But then you have to do it with the pressure of being the final exam in a limited amount of time. And then plus on top of that, it's really hard to give partial credit. If a program does not even compile, it's hard for me to assign partial credit, because what is a closed curly brace worth, as opposed to using a if when a while is needed. One is a syntax error, because I just forgot to close a curly brace, but the program did not compile. The other one does compile, but it's a conceptual problem, where you need to use a while, somebody put in an if, that's a conceptual problem. So it's much harder to assign partial credit in that case. In this, I am assigning partial credit by, okay, let's see what your output is and whether it indicates you understand these concepts or not. All right, any other questions? No other questions? So I'm going to stop the lecture recording. If you guys have any questions, I can answer that. If not, you can